Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to configure static routes. Are you ready? Let's get started. Alright, this is our today's scenario which has been implemented in EventG. We have three routers, router 1, router 2 and router 3. And these are the subnets that we're going to use from 192.168.1.0 to 4.0. And the green numbers are the IP addresses that has been set on the interfaces, or we're going to set some of them. To do a bit of recall, I left the IP configuration of router 1. I haven't configured it, so we can configure it together. But the IP addresses of these two routers have been configured and they're ready to go for static routing. Before configuring any IP addresses on this router, I want to show you how does the routing table look like on a new router. To check the contents of the routing table, we run show IP route. This is the command that shows the contents of your routing table. Which routes are available in your routing table. As you can see, this is a new router. There is no any configuration on it, so the routing table is completely empty. But what I want you to have a look are these codes. As you can see, there is a code for each individual type of routes. For example, C for connected, S for static, R for RIP. These codes will help you when you have a router with like hundreds, thousands, sometimes millions of routes in it, and you want to see where does a specific route coming from. Is it coming from BGP? Is it coming from OSPF, etc.? And when you run show IP route and it lists the routes that has been installed in the routing table, with these codes, you can figure out what type of route is that one you're looking for. Now let's start to configure IP addresses on this router and see how it impacts the routing table. So I start with gigabit Ethernet 0/0. Intentionally, I chose a layer 3 switch image for this emulation in EventG to show you how you can deal with layer 3 or multi-layer switches as well. So to configure an IP address on an interface, you know that we have run through this before. So you have to go to the interface. So pick the interface gigabit Ethernet 0/0. Since this is a layer 3 switch, if I run type IP, you can see that there is no address option here. Why? Because this is a layer 3 switch and all of its interfaces by default are in layer 2. So first I need to change the type of the interface with no switch port command. No switch port takes the interface to layer 3. Now we have the option to set the IP address on it, and the command to set an IP address on an interface is IP address, and then the desired IP address, which in this case is 192.168.1.254, and then 255.255.255.0, which is the subnet mask of that interface. So now we set this IP address, and as you can see, this interface state is up. So now, if I check the contents of the routing table again, you can see that a route has been added to this routing table, and that is 192.168.1.0/24, which is directly connected to gigabit 0/0, and also the individual IP address of the router, which is 1.254/32, and it is connected to gig 0/0 again. Now these codes can help you to figure out what type of route is it, and you can see that it is a connected route. That means that this network is directly connected to the router. Let's go to the next interface. Interface gig 0/1, and the IP address on this one is sorry, first we have to take it to layer 3, and then IP address 192.168.2.1 with the subnet mask of 255.255.255.0. And obviously, if you're dealing with a router, you don't need this part. This is only happening when you're dealing with multi-layer devices. And by default, or for whatever reason, you configured that interface before to layer 2, etc. Anyway, that interface is in layer 2, and you have to take it to layer 3 to be able to assign an IP address to that interface. So to check the routing table again, there should be 2 directly connected routers, as you can see, 192.168.1.0 and 192.168.2.0. Before configuring routers, routing, etc. on your routers, especially for the first time, you need to make sure that your point-to-point connections are fine and you can see the next hop. So in this case, in this router, I need to check, for example, ping 192.168.2.2, which is the IP address of this router. And if the ping replies, that means the communication between router 1 and router 2 is established and they can see each other. You have to do this step by step. I mean, from router 1 to router 2, from router 2 to router 3, and even from your endpoint to routers, to the routers. I mean, for example, in this scenario, from this PC to the router, you have to check that if this communication is fine. So for this router, if I can ping 192.168.1.254, 254 is the router itself. 1.1 is the PC. So if I can ping it, it means that the communication between the PC and the router is fine. But now, if I try to ping 192.168.4.1, which is router 3 gigabit Ethernet 0/1, you can see that I cannot do that. It's impossible. Why? Because simply I don't have any route that can help me out to reach out to that specific subnet. My router only knows about 192.168.1.0 and 2.0, and that's it. So 192.168.4. something, it's not in the routing table, so router cannot route the traffic destined to that subnet. Another tip for routing on multi-layer switches, on some multi-layer switches, by default, routing is not enabled. So you may need to run this command in global configuration mode. And that command is IP routing. And this command will enable routing on that multi-layer switch. But obviously on the routers, again, you don't need to run this command because it is enabled by default. So now is the time to configure the static routes. Before configuring the static routes, you need to design it. You need to know what sort of routes you need to add to your individual router so all of the IP subnets can reach out to each other. For this scenario, on router 1, we have 192.168.1.0 and 2.0 as directly connected. And if we have a look at the remaining subnets, we only need to add routes for 192.168.3.0 and 4.0. And to add a static route to your routers, the command is IP route. And then you mention the destination. And the first destination we want to add is 192.168.3.0, the address, and then 255.255.255.0 as the subnet mask. And now we have two options. First, mentioning the outgoing interface or the IP address of the next router. Both of them are possible, and or even both, you can add both of them, not only one of them. But the thing is, if you're dealing with Ethernet or multi-access networks, it is recommended to use the next hop IP address because you don't need to do ARP queries and responses every time you send something out. But for a small point-to-point network, you can use the outgoing interface as well. So my personal advice is add the IP address of the next router, which is 192.168.2.2 in this case. And same thing for 192.168.4.0. So now, if we have a look at the routing table of this router, you can see that we have two directly connected routes and we have two static routes, which are determined by the S code. And it says 192.168.3.0/24. It is reachable via this one. We'll talk about this one in the upcoming videos. Okay, so for now, just focus on the destination and the next hop. Okay, now let's jump on the router 2. If we check the routing table of router 2, we can see that we have 2.0 and 3.0 as the directly connected networks to gigabit 01 and gigabit 00. So we need to add one route destined to 1.0 and one route destined to 4.0, and they go to different directions. So to configure 1.0, we say IP route 192.168.1.0 255.255.255.0. Now your next hop is router 1, and that router 1's IP address is 192.168.2.1. And for 4 network, the IP address, the next hop is different. And for that one, the next hop is 3.2, which is router 3. So you need to be careful where do you send your traffic, otherwise your end-to-end delivery will not work. And finally, router 3. For router 3, we have 3.0 and 4.0 as directly connected routes. So we need to send the traffic back to 1.0 and 2.0. But on this router, I want to show you another type of route you can add it. And that route is the default route. The default route means that all traffic. If you have any specific route for a specific destination, next hop, use that route. But if it doesn't touch that route, sends it out through this route I'm talking about. What does it mean? Let me show you in practice. So at the moment, 3.0 and 4.0 are directly connected here. And there might be like tens of other subnets in other directions. So instead of adding one route for 2.0 and one route for 1.0, one route for X, one route for Y, etc., we can add a default route on router 3 and add it to all, apply it to all other subnets. This default route is normally used on the edge routers when your device is connected to the internet. So you cannot add individual routes for all IP subnets on the internet. So you just add a default route to your router and send it to your ISP. But anyway, wherever you need to do this, instead of adding individual routes, especially when you have only one next hop for reaching out to all subnets, like router 3 here, or even router 1, they only have one next hop. There is no any other routers connected to them. So it makes sense to add one default route and send all traffic to the next hop. Okay? If you have a look at here, this option, gateway of last resort, is not set. Gateway of last resort is that the same thing I talked about. That means that if you have individual routes for specific destinations, okay, go through that and send the traffic accordingly. But if no other routes match your traffic, then use the gateway of last resort, which is basically your default route. So instead of adding individual IP routes for 2.0 and 1.0, I say IP route 0.0.0.0 with the subnet mask of 0.0.0.0. This means that all subnets, okay? And then who is your next hop? Your next hop is 192.168.3.1, which is router 2. So now if I double check the routing table again on this router, show IP route, you can see that now the gateway of last resort is also configured for network 000, which is all subnets. Now I'm expecting PC1, which is this PC, 192.168.1.1, and be able to ping all of the available IP addresses in our network, I mean live host in all subnets. I start with the gateway, I mean the router 1 interface gigabit 0/0 that is directly connected to PC1. So 192.168.1.254, as you can see, it is pingable. So my first hop is fine. So I go to the next hop and ping 192.168.2.2, which is router 2. You can see that I can ping it. And I do same thing, router 3 interface, and then it's fine. And finally, the PC2 IP address, which is 4.1. And as you can see, all of these subnets are pingable. So yeah, this is how you configure a static route. The only thing you need to make sure that two things actually. First, routers need to have the routes for specific destinations if you want to be reachable. And the second is try to minimize the number of routes on your routers. This is an emulated network. It's not a big deal. But when you're dealing with enterprise networks, the more routes you have in your routing table, the more processing time will take for your router to process and find the best route for a specific traffic. I know the current routers in the market are huge. They can handle millions of routes, some of them, not all of them. But yeah, it is always recommended to keep the number of routes as low as possible to reduce the amount of resource usage on your router. Alright guys, this was our today's video. In the next video, we'll be configuring IP version 6 static routes. I wish you enjoyed today's video and see you in the next one.